John Hedlund-Fay, and today I'll be presenting for you my research into a context-enriched NL-to-SQL agent for Premier League football database querying. Prior to conducting this research, I worked professionally for the Premier League, managing their relational databases for many years. English pyramid football is a highly error-intolerant domain where failure to comply with regulations can result in huge fines, match invalidations, and even suspensions. As such, the database queries that I dealt with in my work were often tremendously long and complicated in order to represent the logic of the laws of the different administrative bodies that affect professional football. In the course of that work, I had investigated if an out-of-the-box large language model could be a useful tool in turning the natural language questions of league and club managers and administrators into SQL, but this was largely unsuccessful. Existing NL-to-SQL systems already struggle with enterprise-scale SQL complexity, but the more interesting problem to the football administrative domain specifically was a semantic one. The logic governing the data often lived outside of the schemata in external rulebooks. Terms and jargon with important rules definitions for the purposes of creating the databases couldn't be gleaned from the schema structures alone. This led me to the purpose of this research. Many early natural language to SQL benchmarks used what is known as a closed world assumption. That is, that all of the relevant information was to be contained within the database schemata themselves. More recent benchmarks, however, have shown that external knowledge and multi-hop reasoning are necessary to represent many real-world queries beyond just the schema alone. In fact, the Archer benchmark specifically identified integration of domain-specific external corpora as an open challenge for NL-to-SQL systems. This made retrieval-augmented generation a promising mechanism for grounding language models in external corpora. Research has already successfully incorporated external knowledge for other kinds of question answering beyond NL-to-SQL, and external corpora pertinent to SQL formation has been successfully used for NL-to-SQL generation. Association football provides a particularly interesting testbed because much of its domain knowledge exists in these very dense, very legalistic documents such as the Premier League Handbook, the FA Handbook, and the IFAB Laws of the Game. These are also living documents. They're updated regularly, and as such are poor candidates for fine-tuning over pre-trained models, and are much stronger candidates for retrieval-based approaches. Many questions that are perfectly clear to football administrators rely on terminology and regulatory definitions that do not appear anywhere in the database schema. This led to the central hypothesis of this work. Would a natural language to SQL agent augmented with RAG over a domain-specific knowledge base outperform conventional NL to SQL approaches on semantically difficult football domain queries? To this end, I investigated two competing architectures. The main point of contrast here is between whether the RAG task ought to be a single monolithic end-to-end workflow or a decomposed pipeline of specialized engines. There's a compelling intuition behind end-to-end contextual reasoning. More context ought to produce better reasoning. If one agent is able to see the entire problem, perhaps it can solve the entire problem more effectively, and many systems have pursued that intuition successfully. Decomposition, by contrast, separates the task into more specialized engines. In principle, this offers stronger interpretability, easier auditing, and reduced contextual interference. Both architectures had pros and cons relative to the problem that I was evaluating, and both felt deserving of a proper architectural investigation. The first architecture that I present here, which I called RAG-C, C for context augmentation, operates in two steps. First, the external corpora of the FA and PL handbooks and the IFAB laws of the game were densely embedded. Then the RAG retriever was provided to the broader agent as a tool, known in this case using the LangChain framework as an agent scratchpad. Then the retrieved context, the few shot examples, and the SQL generation prompt were composed together into a single reasoning context. The second architecture, which I called RAG-R, R in this case for query refinement, by comparison uses the same dense vector stores and the same user prompts, but instead uses a query refinement system prompt to have the first large language model act as a query refinement engine. Those refined user prompts were then passed along to the same SQL expert along with prompting examples and reasoning. In order to evaluate these architectures, however, I had to construct a benchmark that was specific to the kind of domain knowledge that I wanted to evaluate, and which included questions depending on external semantic constraints, in keeping with the open world approach of many contemporary benchmarks. To evaluate these architectures, I constructed a 400 question benchmark over a representative subset of publicly available transfer marked data. While this representative subset was substantially smaller than the real enterprise databases used in professional football administration, the resulting schemata still consisted of a dozen interconnected tables, over 80 columns, and hundreds of thousands of data points drawn from 13 years of Premier League competition. Transfermarkt was chosen specifically because it provided a realistic football data environment while remaining fully publicly accessible, allowing future researchers to reproduce and extend the benchmark. The first three sets of questions were designed specifically to demonstrate the robustness of this benchmark. The questions across these sets featured increasingly broad and deep SQL syntactic difficulty. The third set of questions in particular often required complex common table expressions, windowing functions, and joins across many tables in the representative data subset to be as reflective of real enterprise queries as possible. The fourth set, however, differed from the rest of the other three. Difficulty 4 questions were less complex syntactically on average than difficulty 3, but consisted of prompts which all specifically required domain-specific knowledge. Consider this question here: which club automatically qualified for the FA Community Shield in 2024? It's unclear from database information alone how to resolve and answer this question, but by disambiguating the statement with the external rules knowledge that the Premier League winner always automatically qualifies for the Shield, made the prompt resolvable with the provided database tables and columns. So once this benchmark was constructed, I was then able to tune and validate across many configurations and find the best non-RAG baseline on which to build the two RAG architectures that I was comparing. 10-shot chain of thought here had the best execution accuracy and exact set match on the validation set and formed the basis for tuning the RAG-C and RAG-R pipelines. So this table shows the final results of the two RAG architectures that I compared on, specifically on the most syntactically and semantically difficult questions compared against this best non-RAG baseline from a held out test set of 360 questions. What's particularly interesting here is that on the semantically difficult questions, the monolithic agentic architecture actually failed to outperform the best non-RAG baseline, whereas the decomposed pipeline more than doubled exact match accuracy on difficulty 4 questions. To further understand these results, a case study was conducted into why the decomposed pipeline outperformed the best non-RAG baseline, and more interestingly, why the agentic flow didn't. Analysis into the agent execution chain from RAG-C showed that a lot of the problem was relevant context being lost in the middle. The order of the presentation of the prompts was embedded context, database construction and examples, then the few-shot examples, and finally the prompt to do chain of thought reasoning. Because of this, while the retrieved context in the agentic workflow was often correct relative to the user prompt, and the chain of thought reasoning of the prompt was sound, the agent would often hallucinate columns and tables based on the retrieved context from the external corpora that weren't present in the database at all. In this example shown, which Premier League clubs are closest to the maximum limit of non-homegrown players in their 2024 squad? The RAG-C agent placed its attention on the wrong part of the question relative to the solution and fetched the legal criteria of homegrown status and tried to formulate how to get to that homegrown status from first principles instead of using the existing foreigner's number from the transfer-marked data. RAG-R, by contrast, was able to extract the correct rule from the external corpora, and you can see from the refined prompt here, was able to formulate a better user query with the missing disambiguated information necessary for the SQL generation step to then remain relatively straightforward. So in this case, having two models, one that was just for the prompt refinement and one that was just for the SQL generation, succeeded in not overloading either with context and allowing both steps to leverage their full strengths. This research addressed the critical semantic gap in enterprise NL-to-SQL generation. Publicly available large language models and conventional in-context learning prompt engineering techniques alone have been insufficient to tackle enterprise-level NL-to-SQL. Further, the nature of the corpora in the management and administration of professional football as uh, annually updated living documents makes them ill-suited to fine-tuning. The direct augmentation agent, RAG-C, failed to outperform the best non-RAG baseline, confirming that stuffing the complex regulatory text into the generation context exacerbated the lost in the middle phenomenon, leading to hallucinations. By isolating the retrieval and disambiguation of the domain knowledge from the SQL generation step, the decomposed modular pipeline, RAG-R, was able to effectively bridge the gap between ambiguous user intent and rigid database schemata. These findings suggest that in high compliance enterprise environments like this, that shared contextual reasoning can also introduce contextual interference. Under similar semantic and regulatory conditions of high compliance enterprise environments, structurally separating interpretation from generation may provide both stronger performance and more interpretable failure modes. While these results were promising, several important directions remain for future work. The benchmark that I constructed was authored by a single domain expert. Future iterations should incorporate multi-expert validation to strengthen the benchmark robustness. Additionally, there are more advanced evaluation metrics for NL-to-SQL, like semantic equivalence, that could be used to get a stronger measure of logical correctness beyond exact set match alone. And finally, further generalizability research is needed to evaluate whether the architectural effects observed in this research persist across other language models and other enterprise domains. Thank you for your time and attention.